Sam with Nexus Workshop, and we are walking through all the different inputs and outputs available on the Nexus Ultimate Prop Controller. Now, we've covered digital inputs. The next one we're going to talk about is our outputs. And this is going to be, we're going to go and cover a lot of different output types at the same time. The first one, the one that everybody's going to have, is the relay output. So that is, I want to drive a relay, and that is going to switch a powerful source. We haven't fully dove into the electronics of it, but just know that this is not a power supply. This does not power your mag locks. This does not power your things. Instead, it's got this 12-volt power connection that is powering it, and that same 12-volt could be powering your other things. But you need to switch that circuit with a relay. And that's true universally for how controllers like this work. If you want to get it built out from us so that you just have a maglock output, we can definitely build that for you. We have options to buy that directly on our store with our build your own kit, or you can always reach out to us and get a custom build just to throw that relay on, do this internal wiring, and there you go. Or if you want to, you can do it yourself. That gives you the most flexibility, the most options, and is going to be the cheapest cost, but you have to build out a little bit more. So for maglocks or solenoid latches are both going to kind of behave the same way. Those are going to be typically 12 volt, though I know on the latches sometimes I know someone who likes to drive them at 24 volt just to kind of make them kick a little harder, and because you're turning them on and off, that's fine. For maglocks, you definitely don't want to power them too high because they will overheat, and so those are typically a 12 volt maglock, and then you need to have enough ampacity and current available on it. We're going to talk about wire gauge and current a little bit later, but for right now, just know that your circuit-wise, what you're going to end up having is your power supply for your magnet. You're going to take the positive line off that power supply, and it's going to go through a relay and then out to the magnet, and then your ground line is just going to go to the magnet, and that's your simple circuit. I got my power and my ground, my plus and my minus, and then it comes through my relay. The plus comes through, gets switched, so that's where we're breaking or closing the circuit, and then those two wires go to my maglock. Now there's one more piece that you're going to have in there, and that's a flyback diode. It can be pretty much any diode, but a flyback diode, a diode, is a little circuit or a little piece of a circuit that's a component that only lets voltage pass one direction. Light emitting diodes are like this. They are light emitting, they make things light up, but voltage only passes one direction. You're not going to use one of them, you're going to use a regular diode or a Zener diode. But it's going to let voltage pass from one direction. And you're going to put that between your positive and your negative lines. You're going to put that, theoretically, close to the maglock. Now, if you put that in the direction where it lets voltage pass from positive to negative, it's going to instantly blow itself up. It is going to melt, explode, go away. You are going to actually end up putting that backwards so that voltage cannot, in its normal thing, pass through. What this is going to do is when you take a maglock and it's got its iron plate on it, when it releases and that magnet comes off, it actually sends a spike of voltage backwards through the circuit. If that comes back all the way, it can cause transient issues where it's messing up your ground reference or sending a spike, and it can reset any controllers that are on, and this is not specific to us, this is a general Arduino thing. It can reset the controllers and make them reboot or cause damage to them. So that flyback diode is going to help shunt all of that extra back voltage back down to ground. And so you're going to run it backwards between the positive and the negative. Now, the way you can tell which direction it goes is on that little diode, it's going to have a line on one side of it. That line is the direction the voltage is going. So that's the exit that the voltage is taking through that diode. You're going to put that backwards. So you're going to put the little line on the positive side and the no line on the negative side, shunted straight across. And like I said, now when that maglock turns off, the circuit's been killed, it's going to take all that voltage and shunt it backwards through there, and it's not going to get through your controller. Now, that is not always enough. Whenever I'm building props, whenever possible, like if I'm building out full rooms, instead of having a power supply on every single prop and every device, I will instead have a big power supply centrally located that's feeding all of my different things, or sometimes several in kind of co-located positions. But I'll use big power supplies, 30 amp or above, and then run all of my lines out to my things. Now, whenever I do this, I always give myself a clean power supply and a dirty power supply. So my clean power supply, in this case, they could both be 12 volt because I can power my boards off of 12 volt. So I could do two 12 volt power supplies, but I make sure that they are never actually connected to each other electrically at any point. Usually when you're using multiple power supplies, you're going to tie the grounds together to make sure that things can use voltage from different rails and communicate and have the same reference. I'm not going to do that here because that dirty ground is my problem with maglocks, with solenoid latches, with all the things, big motors, the things that kick, the things that suddenly do big swings, send these little spikes and issues into my lines. And that is what causes my controllers to reboot, reset, lose themselves, have issues. So whenever I'm working with those, I do a dirty power supply, which is the same power supply, but I label it as dirty. And that one powers all of my maglocks, my solenoid latches, my dirty elements, while the clean power supply runs all of my controllers, it runs all of my modules, my electronics, my more sensitive things. Because I have that relay, and that's how I'm handling it, I can just hook up my dirty power to there, hook up my clean power to my thing, and they're completely isolated. They're separated. That relay is the isolation. Getting back to relays. So we've talked about how I would hook up a maglock to it. We talked about the flyback diode. We talked about isolating the power supply from that. On single little props, if I just have my power supply for my one prop, I do the flyback diode, and I'm probably using the same power for both my maglock and my controller, and that's how it is. But that is that. If I were to have a solenoid latch instead of a maglock, with the eMag, it's going to be on all the time, and it is what's considered fail safe, which means when power gets killed, it opens up. This is really good for things like doors and stuff like that. Anything with security and people involved, you definitely need to have emergency exits buttons. Anytime anything can possibly lock someone in place, even if the game flow says that it never will, you need to have that. And I would just put that button in line and just make it break the circuit. So there's no controller, there's no nothing. It's literally when you push the button, the wires are not connected, the maglock opens. Solenoid latches on the other side are fail secure, which means when power is lost, they don't open. So now you need to have like little holes drilled inside of your cabinet so you can hit the latch manually if a wire breaks or something happens and the latch burns up, you can't get it open. You have to have a solution for that. And you should not use latches anytime you have something that people could get stuck in, a door that doesn't have another exit, something like that. With your latches, they cannot be powered all the time. So with an eMag, you have your prop is not solved, the relay's off, prop is solved, the relay's on, there you go. With your solenoid latches, they have to trigger for a short burst of time and then turn off, because if you leave them on, you will burn up the latch. It will melt. The coil will stop working, and it'll get stuck in a state. The way the prop controller handles this is it has a thing called flash mode. If you enable flash mode, the default setting should work fine for you, but you just check the box, and now the relay cannot be turned on and left on. If you hit on, it just hits flash. So it'll hit it for, by default, it's a quarter of a second, and then let go. This is really good for handling latches, takes all the hard work off of you, so you don't have to think about it, don't have to remember, did I turn it off, how long did I turn it off? Another thing I've seen people do with solenoid latches is hit them multiple times to make sure that it releases. So there's a feature in flash mode called repetitions. So you can set how long you want it to flash for, and you could set it to say, hey, I want you to always hit 3 times. And then it'll click, 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 click. It'll 3 flashes on, off, and that'll be its thing that happens every time you hit flash or every time you hit on. We've kind of taken the hard work off of those things. Now, talking about relays, you have both 5 volt and 12 volt relays are the most common ones on those little modules that you can get. You're going to want to be using 5 volt relays. That's going to be the easiest way to power it off the board and then have the I/O pins drive it up and down as it needs to. There are also relays that are high level trigger or low level trigger or either. You can use either inside the prop controller. There's a little checkbox as you add it to decide if it's a high trigger or not. So you can flip that behavior and make sure that the logic works the way you want it to in your head as you're doing these things, because the controller's going to take all that off for you. Outputs. The other output we'll talk about is pulse width dimming. So this would be if you had like a traditional LED hooked up to it. I don't really see a lot of use for this anymore because of addressable pixels. They're so easy and give you so many more features. But if you wanted to have traditional dimming for reasons, then you can have that there. And so that is a simple output that you can build, an analog PWM output, and that's going to let you drive it from 0 to 255. And that's going to, what it does is it turns it on and off really fast. And in doing so, it takes the average under the curve. If you were to measure the voltage on a curve, it takes the average voltage down. It's not actually reducing the voltage. It's just turning it on and off really fast, high voltage. But for things like LEDs, it can make it optically dim because our eye says, hey, over time, my eye isn't reacting that fast. Over time, it looks like it's less bright because it's on less. And there are other things that can also be pulse width controlled, motors, for instance. Now, a motor or a big LED source, I don't want to be powering that off my board. These things are not designed to power anything. And so if that was the case, what I'm doing, something like an LED, a little one, fine. If I'm doing like a bigger LED, a big module or something, or, like a big 12 volt bulb, then I could run it into a transistor module. Those are also pretty affordable. You can find them on Amazon. But a transistor module is going to let me hook up my analog PWM output to it, and then it can actually switch to the higher voltage. You'll need to look up a little bit about how those get connected, but typically it's going to have a power, ground, and signal coming from the board, and then the actual thing it's switching, which also lets it have its own power supply that it is sourced from, so that we can switch those or dim those bigger sources. And you can do some pretty cool things with that. Different transistor modules will have different amounts of current they can handle with heat, all those things, but you can dim down pretty big bulbs. Now, if I have a bunch of them, I'm probably gonna go DMX and put an actual dimmer in there. But if I just have one or two or something, I just have like a practical light that I'm trying to make, pulse on and off or something like that, great, this is a great way to do it. And unlike a relay, the relay can only turn on or off, and it can't turn on and off that fast. You'll burn up the thing. A transistor can turn on and off as fast as I want, which means I can also pulse with it. There's another option in the middle of there called a solid state relay, which is a relay that doesn't have a moving part to go click. You can use those as well. That would behave just like a regular relay. There's just a little bit of difference in how you would wire it up and how you would connect it. And when you would want it, when you would want that over a regular relay. Again, they don't click, and they can be switched on and off much faster, but they have more limitations around like what they're doing. You're not going to use them for dry contacts. They're going to be used to power something like a maglock, and you are going to have to make sure you get the right one for DC versus AC, because if you get an AC one and you try to switch a DC circuit on it, it can't turn off. It'll turn on the first time and then it'll stay there, and it won't turn off until you pull power to it. But that's also another type of relay that exists that you could use, is those little, they're that big white square ones. And anytime I'm switching AC current, if I'm switching mains power, I try to avoid it. I really don't like doing it. This is on you, no disclaimer here. But if you end up having to do something like that, that's usually the way to do it. Make sure you're being safe, make sure you're being careful, make sure you know what you're doing, get someone who does. But that's my little disclaimer there. I think that's going to be it on outputs. Next, we're going to talk about inputs, and then we'll talk about input modules.